Let's talk now about the chapter 1.5a quality of service components. This is a summary of what are the quality of service components, and don't freak out because I'm going to later on have a particular session about every single one of these components, talking about the configuration. This is just a summary of what components are out there, the definition of each component, and what are the particular Cisco features for these components. Remember that these are Cisco features. Some of these Cisco features you are not available in other for other vendors. Remember that these are particular Cisco details. So remember, this is a summary. Let's go for the first quality of service component, which is trust. Trust means allowing incoming traffic retain its DHCP or COS value. In this sense, the classification happens by trusting the existing marking in incoming traffic. So what are the features that we have with trust in Cisco? Every single switch port in Cisco may live in two states: in trusted state or in not trusted state. So in trusted state, the traffic, the marking that exists in these trusted ports will be passed through. And when a port is in a not trusted state, then that traffic will be subjected to remarking or mutation, marking or mutation. So just remember that. And we have another feature with Cisco, which is conditional trust. This means that some rules are applied to each port in a switch, and after applying these rules, then the switch will decide whether to put the port in a trusted state or not trusted state, and this happens dynamically. That is somewhat cool. Let's go for the next quality of service component. Classification by ACL means distinguishing one type of traffic from another. Historically, the only way that we had back in the day with old switches in order to perform classification was using an ACL. But nowadays, with the modern switches, we have other means to do classification. So we could still use ACLs, IPv4 ACLs, IPv6 ACLs, MAC addresses ACLs. But in current switches, you can classify by matching VLAN number, quality of service group, missing MAC addresses in the MAC address table, packet size, the scalable group tag. Remember, scalable group tag from SD Access. So we can match on a scalable group tag. And we can use a cool feature which is MBAR. Which MBAR you can classify by using a protocol. For instance, you can say, I want to classify all the YouTube streaming. And that will be mainly impossible to do with traditional ACL. So using MBAR is great. And with you can use MBAR also with wireless. And we have another technology, which is the evolution of MBAR, that is known as application visibility and control. Let's go for the next quality of service component. It is marking. Marking means conveying, propagating, or bearing traffic type information or modifying it. What are the features that we have for marking? With Cisco, we can do conditional marking. When using conditional marking, we are going to make use of policing and unconditional marking. In this case, we're going to use the command set. And we are going to store our markings. We're going to use layer 2 headers in order to store our markings, or layer 3 headers. Fields, layer 3 fields within the layer 3 headers. And for wireless, we can use CAPWAP, TCP, or user priority. This is a feature that exists in the wireless, in the over-the-air traffic. So we can mark traffic that is traveling over the air, which is actually cool. And let's go for the next quality of service component. Mutation means using a table map to change markings, usually the DHCP. This usually happens when you have a switching domain that does not belongs to you, that is connected to a switching domain that you are managing. Probably the administrator of this switching domain says that the video should have a DHCP value of AF 31. But then it enters your switching domain, and for your domain, you say that video should have a value of AF 41. That means mutation. So you're going to change this value, and you're going to make use of a table map in order to do so. What are the features that we have? We have our table maps, goes to the DHCP to the DHCP, IP precedence to the DHCP, and so on. There is a feature that you will come across when reading old documentation that is was known as IP DHCP transparency. This is a feature that is the exact opposite of mutation. When you enable IP DHCP transparency in a switch, you guarantee that some traffic will never change its DHCP values when crossing this particular switch. Let's go for the next quality of service component. Policing means imposing a max rate, and then an action is taken for conforming and exceeding traffic. So notice that you're going to take an action for conforming and exceeding traffic, and you're going to impose a max rate. This is usually what is known as per class policing, but in some switches you will see these features. They will call something, they will offer something that is known as microflow policing and aggregate policing. You can have single rate policing, double rate policing, and it will use heavy use of table maps, because remember that policing is related to marking and mutation. Okay, next quality of service component is queuing. Queuing means influencing queue size types and behavior. For instance, queue size in terms of buffers or bytes. For ingress and egress queues, remember that when traffic enters a cart in a particular port, that port will have, for instance, 2 queues for ingress, and it might have up to, for instance, 4 queues for egress. This happens in all switches. For the current Catalyst 9000 series of switches, we have 8 queues for ingress and 8 queues for egress. So you can change the size of these queues in terms of buffers and bytes. And let's go for the next quality of service component, which is scheduling. That means influencing the queue serving time, or setting up some particular queues as priority queues. So for instance, you may have 4 queues, and you may say with scheduling that this is a priority queue that you will use for voice over IP, for instance, or for video traffic. And then this queue you may establish that will be served 20% of the time, and this other queue will be served 60% of the time, and so on. So you can do that with the scheduling. Let's go for the next quality of service component, which is congestion management. And you will use congestion management in order to avoid dropping all packets at a given moment, in order to avoid TCP global synchronization. So what you want to avoid with this is dropping all traffic at once when you reach your maximum rate. So if this is your maximum rate here, and your traffic start growing, and at a given moment, you are going to drop all your TCP traffic, and then TCP will try to recover, and then when reaching your maximum rate, you will drop all your TCP traffic, and then TCP will try to recover. So you will end up with some traffic behavior like this, and what we want is to make it a little bit more smooth. So in order to do that, you will want to drop traffic not at the same time, but at different times. And in order to do so, we have several options. We have a weighted tail drop, or we have weighted random early detection. And let's go for the next quality of service component, which is shaping. Shaping means imposing a max rate, regulating the traffic, queuing it, and using buffering in order to store your traffic. Remember that we are also imposing a max rate with policing, but with shaping, we are going to have a more smooth traffic behavior, because you're using queues and buffers in order to store your traffic, and you can actually smooth the way that you send your traffic out an interface. With policing, your graphic will seem something like this, because it will be dropping traffic when it reaches the maximum rate. So this is a little bit better in order to use all your available bandwidth, but it usually hurts or includes more delay, and it can hurt voice over IP traffic. And what are the features? You have your average shaping, classic way to do shaping. There is a new feature that is a little bit obscure. I have seen this in the documentation, that is known as sharp profile queuing. And let's go for the last quality of service component, which is bandwidth. This means being able to guarantee or allocate a certain amount of bandwidth per class. So you can have, for instance, a voice over IP class, a video class, a database traffic class, and you can set with this bandwidth component that you might want to guarantee 1 megabit per second to this voice over IP class, maybe 5 megabits per second for your video class, or 15 for instance, and 50 megabits per second for your database class, and so on. So you can allocate bandwidth by a percentage, an absolute value, remaining value, and so on. So in summary, these are the components. This is the description. And you might want to pause the video here if you want to review all the description of all the quality of service components. And these are the features. The features are Cisco particular features for quality of service. So if you go for another vendor, you might not have trusted states, you might not have MBAR, you may not have conditional marking, you might not have microflow policing, but with Cisco you will have it. These are particular Cisco features, and these are the theoretical description for each of these components. In later sessions, we are going to see how to configure these components, and in more detail, how to configure these features. That's it.